Hello, this video is being made for the AE 341 lab course. We will cover how to take your data from Excel and plot your data using MATLAB for Lab 5. First thing you want to do is open up a new MATLAB window. You always want to write your comments. So creating it for AE 341. And to plot pipe flow results. You always want to add these three lines to the beginning of your code. It will close all the windows, clear everything in memory, clear everything on the screen. By adding a percent in front of anything, you can comment out lines. So we'll have a rectangular weir. This is going to be the head. We'll call this head rectangular. I'll leave that there until we get our actual data copied in. And do the flow for the rectangular. And we're going to do the same for the V shape. So I'll use HV for head of the V shape and QV for the float of the V shape. So this ends our user inputs. And next thing we're going to want to do is we're going to want to convert our units. You can either manually convert them in Excel, or you can pull them from your Excel sheet into here and just have MATLAB convert them. So I'm going to have MATLAB convert them. I'm just going to say the head of R is equal to the head of R times 0.1. This will convert millimeters to centimeters. Same thing with the flow. So I'm going to multiply this by a million. This will convert metered cube per second to centimeter cube per second. And I want to do the same thing for the V shape. So now I've converted my units. And we want to start our calculations for the rectangular weir first. So we're going to say we're going to put everything in terms of x and y. That way we can just change the x or the y depending on whether we're using the rectangular or the V-shaped. So we're going to say x is equal to the head of, or the height of the rectangular weir and y is going to be equal to the flow of the rectangular weir. So we want to take that data and we want to get our least square fit. So it's already built in MATLAB where you can use this polyfit. We're going to be taking the log of x, log of y, and it's going to be a linear equation, so we use 1. So y least square fit is equal to exponential p1 times log of x plus p2. Next, you're going to want to plot your original data. We'll call it P1 equals log of x and y. We're going to make these red circles. Next, we want to create labels. So we'll call them labels equals to the cell string. We're going to say we want a number, so the string, from 1 in increments of 1 to the length of x. Close our brackets. And we want to add the text to the plot. So text of x, y, add the labels, and we're going to place them vertical alignment. At the bottom of each point. And with horizontal alignment, we're going to put it to the right. Nice little trick if you don't want to fit stuff on the really long so you can't see it anymore. You can put 3 dots and move it to the next line. That will continue your code on the next line. So now we want to add our least square fit data. So we'll do hold on. We will plot the laminar, or we will plot our least square fit line. Call this P2 is equal to log x, y least square fit. We will make this dashed dot line in, I believe it's black. We want to add labels as well. We would like to have the slope and the k value on the plot as well. So label 1 is going going to be equal to, we're going to call it the rectangle slope and we want to pull the calculation as a number string onto our plot. That will bring in the rectangular Weirs slope. Call label 1k because this is going to be the k value. Rectangular k equals to, and again we're just going to pull the calculation, which is already being done by MATLAB. Don't forget to close your brackets. There we go. We just finished plotting our least square fit and our original data. We click run. Well, we need to bring in some data here. I'm going to go ahead and copy in some data from my Excel sheet. Just select the cells, copy it in directly. Alright, now I have some data. I can click run, and we have one line on there with our points labeled per run and our least square fit line. So to get the second one, we've already created everything in terms of x and y. So from %calcs on down, we just want to copy that. We can paste it below it. On the second part, we will go ahead and change x this time to HV and y to QV for the V-shaped weir. The equation for least square fit stays the same. It just gets repeated. We're still wanting to plot our original data on there as well. We can get rid of the P1 here. And where we used to have P2, we're going to go ahead and make this P3 to add another label to that plot. And where we had label 1 and 1K, we'll change it to 2. And now it goes from rectangle to V-shape. So I just copied the code from earlier since everything was in terms of X and Y. And I was just able to make a few changes to apply it for the V-shaped weir. If we look at the plot now, we have two lines, one for the V-shape, one for the rectangle. We don't really can see the difference between the two because the colors are the same. So we want to change the color. We'll go ahead and change the color of the V-shaped to red. And a few more things you want to add. We want to add a title. This is going to be the log Q versus log of H. We're going to want to put an X label, H, and this is in centimeters. Y label, this is Q, and this is in centimeter cube per second. We want to add a legend. We had plots, we had P1, we had P2. We want to make a second P2 because we had two labels for P2. We had label 1 and label 1K. Same thing with P3. We want to go ahead and call the first name. We're just going to call it the experimental data. This is the raw data or original data that you plotted. P2 is going to be label 1. The second P2 is going to be label 1K. P3 will be label 2. And label 2K. Move it to the next line. We want to specify the location as the best possible location. And the last thing, we want to set our axis, X and Y axis, to from 10 to the power of 0 to 10 to the power of 1 on the X. And on the Y, we're going to go 10 to the power of 2 to 10 to the power of 3. And now let's go ahead and plot this. You can see our x-axis and y-axis have been scaled. Our colors are now different. Experimental data is shown as circles. Least square fit lines are there. Everything's properly labeled. Only thing left is you want to turn the grid on. So you can turn grid on, run it again. Now we have a plot with grid lines properly scaled. And that wraps up this video on how to plot pipe flow using MATLAB.